We've talked about improper fractions before. Those are the fractions that represent more than 1 or equal to 1. Improper fractions can also be represented as something called a mixed number. Mixed numbers contain a whole number and an improper fraction. So I've got 3 different representations for the same mixed number on the screen. In circles, I can see that I have 2 completely filled in yellow circles, and then 1 yellow circle that has 2 parts out of 5 filled in. So I can tell that I have 2 full circles and then 2/5 of a circle shaded in. Now what I'm saying is that improper fractions represent that same mixed number, so if I were to have divided my circles, even the whole ones, into 5 equal-sized parts, then I could count that I have 5 out of 5 from the first circle, another 5 out of 5 from the second circle, and then 2 out of 5 from the third. And when I add these like fractions together, I'm really just adding the numerators, 5 plus 5 plus 2 over the common denominator of 5. That would be 12 out of 5. So the mixed number 2 and 2/5 is the same as the improper fraction 12 out of 5. Now, when we want to convert a mixed number to an improper fraction or an improper fraction to a mixed number, sometimes drawing it out is not the fun way to do it. That's because you might have to draw a ton of circles, cut them all up, and that's quite a bit of work. But something to realize is that for each of the full circles, we had a complete set of 5 pieces. So what we could do is take the whole number, like the 2, and multiply by the number of pieces. To make a whole. Now that's a long way to say multiply the whole number to the denominator. Remember that the denominator represents how many pieces it requires to make a whole. So you would just take the whole number, multiply it by your denominator. That's going to count up all the pieces that come from the full circles. And then you would just add the number of pieces left over in that partial fraction. So you take the whole number, multiply it to the denominator, and then add the number of pieces in the incomplete circle. That's going to be the new numerator. I've seen some cute visuals for this. If we're talking about 2 and 2/5, I've seen somebody, a student of mine probably, who said, well, from the 5 to the 2, you multiply, and then after that, you're going to add the numerator, and you copy over the old denominator. So 5 times 2, and then plus 2, which is the same thing that we have when we did it visually, piece by piece. And there's nothing that says we can't do this with rectangles or a number line. It would just be a slightly different process. Instead of cutting circles into 5 pieces, you would cut your rectangles into 5 pieces. And then with your number line, notice that we went from no pieces colored in to dividing every whole into 5 separate pieces. So from 0 to 1, I divided that into 5 parts. From 1 to 2, divided that into 5 parts. And I even divided from 2 to 3 into 5 parts. That way I knew how many pieces I had after the 2. Now on a number line, it was not really necessary if we're converting like an improper fraction, to draw all of the pieces between 0 and 1 and from 1 to 2. From this, I could see that I'm making it all the way up to the whole number 2. And then I have 2 out of 5 pieces left. So sometimes we have to analyze what we have, what information is presented to us, and what we're actually trying to get. Are we trying to write a mixed number, or are we trying to write an improper fraction? If you're trying to write a mixed number, then there's no reason to divide up the whole parts. So the full circles should just stay full circles, count them. The full rectangles should stay full rectangles. On the number line, from 0 to the whole number 1 up to the whole number 2, those don't need to be divided if all we want is a mixed number. However, if we want to talk about an improper fraction, then we would need to consider all of the whole parts to be divided down into equal sized pieces as well.